Hi guys, so we are going to continue with the next lecture, still 8.1, the limits. Okay, so at the end of the lesson, students should be able to, the first one, to determine the existence of the limit of the function, and then to find the infinite limits, which is limit fx as x approach to a equal to positive infinity or negative infinity. And then to find the limits at infinity means that we want to find the limit of fx as x approach to positive infinity or negative infinity. And then the next one is to find the limit of fx over gx as x approach to infinity when the limit of fx as x approach to infinity and the limit of gx as x approach to infinity are undefined. And the last one, to use the limit of 1 over x to the power of n as x approach to positive infinity and negative infinity equal to 0 for all n more than 0. Okay, so the first part of this lecture, to determine the existence of a limit. So how can we say that the limit exists? So limit fx as x approach to a exists if and only if the limit of fx as x approach to a from the left side and limit of fx as x approach to a from the right side both exist and are equal. Okay, so in mathematical equations, we may say that limit of fx as x approach to a from the left side equal to the limit of fx as x approach to a from the right side. So if these both exist and equal, means that the limit of fx exists. Okay, so let's see some example on this existence of limits. So given the function fx equal to 2x for x less than or equal to 4 and 2x plus 3 for x more than 4. So determine the limit of fx when x approach to 4 if it exists. Now, to check whether the limit exists at the value when x approach to 4 is by finding the limit from the left side and from the right side. Okay, so first of all, we write down or sketch the function on the number line. So we can see the left side of the x equal to 4 and the right side of the x equal to 4. Different functions. So for x less than or equal to 4, this is for the left side of value of 4. Okay, so we denote as the function 2x. And then the right side of 4 for x more than 4, the function is 2x plus 3. So these will be two different functions to find when x approach to 4. So we want to find the limit of fx when x approach to 4 from the right side. So we choose which function. So approaching from the right side is 2x plus 3. And then from the left side, it should be another function, 2x. So find the limits. So we just have to substitute the value of 4 into the function. So 2 multiplied by 4 plus 3, which is equal to 11. And then from the left side, so we have 2 multiplied by 4, which is equal to 8. So does the limits, the value of limits from the left side and the right side is equal? No, they are not equal to each other. So does the limits exist? No, it does not exist. Okay, so we don't have limits on fx when x approach to 4 for this function. So the next example, given the fx equal to 2 and 5, where 2 for x not equal to 1 and 5 for x equal to 1. So if we sketch on the number line, so we have the function for x not equal to 1 means that it's from the right and the left side of 1. So it's equal to 2. Okay, so we have 2 here and 2 here. And then for the function of x equal to 1, it is equal to 5. Right? Exactly at 1, the function is equal to 5. Okay, so find the limit of fx when x approach to 1. So approach to 1 means that we want to find the limit when x approach to 1 from the right side and from the left side. So if we can see here, limit of fx when x approach to 1 from the right side. So from the right side, what is the function we use? 2. And then from the left side, it is equal to 2. We are not taking the value exactly at x. We use the function approaching to the value of x. So since the limits both are equal to 2 from the left side, from the right side equal to 2, then the limit exists, which is the limit equal to the limit of fx as x approach to 2 equal to 2. Now, the third example. Given fx is equal to absolute of x minus 2, find the limits of fx as x approach to 2. Okay, so this function is an absolute function. So what we can do here is we can define it into two functions. So for x minus 1, positive of x minus 1 means that everything inside the bracket should be positive. So x should be more than or equal to 2. So x minus 2 should be more than or equal to 0. So x should be more than or equal to 2. And then for the negative of x minus 1, so everything here should be negative. Means that x minus 2 should be less than 0. That's why the domain here is x less than 2. So we have these two functions. We can find the limit from the left side and from the right side. Okay, so this is the x equal to 2. So from the left side, left function is equal to negative of x minus 2. And the right function, it should be x minus 2 only. So now we just need to substitute accordingly. Okay, so to find the limits of the function, so we can find the limits from the right side, which is equal to, we use the function of x minus 2. And then from the left side, we use the function of negative x minus 2. So if we substitute the value of 2 into the function, this is 2 minus 2, which is equal to 0. This one also negative of 2 minus 2, which is equal to 0. So both are the same, which is equal to 0. Means that the limits exist, which is equal to 0. Okay, the fourth example. The function f is given as fx or equal to absolute of x plus 1 for x less than 0 and 2 for x equal to 0, and the last one is e to the power of negative 2x for x more than 0. So we want to find the limit of x approach to 0 from the left side, x approach to 0 from the right side, and the limit of x approach to 0. So we find one by one. But before that, we can write down or sketch the function on the number line. So we have 0, x equal to 0, and then for 0 itself, the function is equal to 2. And then we have the left side of the function. The right side of the function equal to e to the power of negative 2x. And then the left side of the function is equal to absolute of x plus 1. So to find the limits from the left side, we use the function of absolute x plus 1. And to find the limit from the right side of 0, we use the function of e to the power of negative. Okay, so substitute the value of x equal to 0. So we have the limit from the left side equal to 0 plus 1 absolute of 0 plus 1. So equal to 1. And then from the limit of x approach to 0 from the right side, we substitute the value of 0. So e to the power of negative 2 multiplied by 0. So e to the power of 0. So e to the power of 0 is equal to 1. So both are 1. So the limit exists, which is the limit equal to 1. Okay, so the next learning outcome is to find the infinite limits. What it means by infinite limits means that when we try to find the limits, the value of limit is equal to positive infinity or negative infinity. So, if the value of fx increase without bounds as x approaches a from the right, we write a limit of fx as x approach to a from the right equal to positive infinity, increasing. And if the value of fx decrease without bounds as x approach to a from the right, we write limit of fx as x approach to a from the right equal to negative. So it decreasing to going to a negative value, negative infinity. And then if the value of fx increase without bounds when x approach to a from the left, so it will be positive infinity. And the same as decreasing, so it will be approaching to negative infinity. Okay, let's see some example on infinite limit. So we want to find fx, we want to find the limit of fx as x approach to 1 from the right side and the left side. So this fx is equal to 1 over x minus 1. So for the right side, so we just substitute what is the function, 1 over x minus 1. So when we substitute the value of 1, we get 1 over 0. But we need to determine which part of 0 is it. So it's approaching to 0, but what 0? So let's say this is the value of 1. So approaching to 1 from the right side. So what value we can take? The smallest one may be 1.01. So 1.01 minus 1 is still be 0.01, which is 0.01 is a positive value. So 1 over 0, we put positive here because it will indicate the sign of the infinity. So 1 over 0, 1 over nothing. So 1 over nothing will be very big value. So the indication here, whether positive or negative, is we see from the right side or from the left side. Okay, that's why the answer here is positive infinity. And then for the limit of fx as x approach to 1 from the left side, so the same function 1 over x minus 1, so we get 1 over 0. So 1 over 0 is infinity, but we need to take note the sign. It will be positive or negative. So if it's the left side of 1, so we can take 0.99 as example. So if 0.99 minus 1, we get negative 0.01. So negative value, that's why we have negative infinity here. Okay? So for example 6, find the limit of fx as x approach to 2 from the left side and from the right side for each of the following function a and b. Okay, so for question A, limit of function fx when x approach to 2 from the left side. So for the function A, we replace with 1 plus x over x minus 2. So when we substitute the value, we get 3 over 0, right? But this 0, we need to indicate whether it's negative or positive. So for this one, the left side of 2 will be 1.99. So it will be 1.99 minus 2 will be negative 0.01. So it's negative value. That's why the answer is equal to negative infinity. And from the right side, so the same as above, we just have to replace the value of 2 inside the function. So we get 3 over 0, but this 0 is a positive. Why? The right side of 2 can be 2.01. So 2.01 minus 2 is 0.01 is a positive value. So positive 0. So the answer should be positive infinity. For question B, limit of fx as x approach to 2 from the left side. So replace the function equal to 1 plus x squared divided by x minus 2 x plus 1. Okay, so after we substitute the value, what we get here is 1 plus 2 squared divided with 0, negative indicator here because from the left side. So 1.99 minus 2 will be negative 0, right? So 0 negative multiply with 2 plus 1. So 0 multiply with anything will be 0. So we have 5 over 0 negative here. So the answer should be negative infinity. And for limit of fx as x approach to 2 from the right side, so the same as above, just we have 0 positive here. Okay, so it will be 5 over 0 positive. So the answer should be positive infinity. Okay, the next part, limits at infinity. So for this part, it's different from the previous part because we want to find the limit as x approach to infinity. Okay, if x move increasingly far away from the origin in the positive direction, so it's going to the positive infinity, and fx gets closer to a value L. So then we write the limits of fx as x approach to positive infinity equal to L. Okay, and then it can be means by this value of x approach to a big value of x. Okay, from the origin going to the right side, so we don't know what is the value of x. It's just big value of x. So it means that x approach to a positive infinity, a big value, and then this value will approach to a certain y value. So this y value is not going to cross the y value, so it's just approaching to the y value. This is what we call as the limit at infinity. Okay, as x approach to infinity, the fx will approach to value L. The same as for the negative infinity. So if x move increasingly far away from the origin in the negative direction and fx gets closer to a value of L, then we write fx, limit of fx as x approach to negative infinity equal to L. So from the graph here, we can see that as x approach to negative infinity, it's going to the left side. And then this graph is going converging to a value of L, but it's not going to cross the L. So x approach to negative infinity, the fx will approach to this value of L. To find the limits at infinity, we must realize that the fact that if n more than 0, then we use this limit of 1 over x power of n as x approach to positive infinity equal to 0. Why? This 1 over a very big value, right? So infinity to power of n is really big value. So we get nothing. We have a very big pizza, but we are dividing with thousands people. So we get just the dust. Okay, so we get nothing. That's why it is equal to 0. And then for b, when limits of 1 over x power of n as x approach to negative infinity, it is the same. We will get 0. It doesn't matter whether it's positive infinity or negative infinity. Because negative infinity to power of n is still a very big value. Negative or positive, doesn't matter. So 1 over very big value will be 0. You got nothing. So let us find the limits at infinity for the following three functions. So for example 7. So limit of x squared plus 3 as x approach to positive infinity. What you need to do? Okay, for example A. What we need to do, we just have to replace the value with the positive infinity lah. So as x approaching to positive infinity, we substitute the x equal to positive infinity square. So infinity square pula, it will be really big number. To add up 3 doesn't matter because it doesn't change anything. It's still a big number. That's why the answer is positive infinity. So for question B, as x approach to negative infinity, so we replace the value of x as negative infinity. So 5 divide with not some value, very big value, will be equal to approaching to 0. Therefore, the limit of 1 minus 5 over x, so it will be 1 minus 0 or 1 plus 0 equal to 1. Because the positive here is negative infinity, right? Negative will be positive. So it is equal to 1. The key point here is this 5 over x will be 0. And then for question C, as x approach to positive infinity, so what is our function fx? X minus 3 all to the power of 3. So we replace the positive infinity inside the bracket. So positive infinity minus 3, it doesn't change the value of positive infinity because it's really big value. So positive infinity to the power of 3 is positive infinity. So limit of 2 over x minus 3 all to the power of 3 as x approach to positive infinity. So 2 divided by positive infinity. So you are dividing 2 with a very big number. Like you have 2 pizza, you divide with 37 million of people in Malaysia. So what you get? You get nothing. So that's why the answer is equal to 0. Okay, the next part of limits 8.1. So limits at infinity for rational function. So this is a special case for rational function. So let's see the definition. If limit of fx over gx as x approach to infinity is equal to infinity by infinity, so we have to divide each term. Divide each term by x to the highest power of denominator. So what is the denominator? The gx. So we have to look at the gx here. What is the highest power of gx? Then every term in the numerator and denominator should be divided by that. Okay. So let's see some examples for limits at infinity. So we have A to D questions here. So for question A, limits of 2x cubed plus x squared minus 3 all over x cubed plus x plus 2 as x approach to positive infinity. So if we just substitute the value of infinity, what will we get? At the top is infinity and the denominator also equal to infinity. So it will be infinity over infinity. Right? So we cannot find what is exactly the limits here. So what we can do now, we determine what is the highest power on the denominator. So here we can see that x cubed is the highest power of the denominator. So everything on the numerator and denominator should be divided by x to the power of 3. So dividing 2x cubed with x cubed and x squared with x cubed, 3 with x cubed, and then x cubed with x cubed, and x over x cubed plus 2 over x cubed. So what we get is, simplify everything here. So we get 2 plus 1 over x minus 3 over x cubed all over 1 plus 1 over x squared plus 2 over x cubed. So if we substitute the value infinity here, 1 over infinity will be 0. And then 3 over infinity cubed will be 0. 1 over infinity will be 0. 2 over infinity will be 0. So what's left is 2 over 1. So the answer should be equal to 2. So for question B, so we can see the same as question A, that we will get infinity and infinity. So negative infinity over infinity is not negative 1. So we don't know what is exactly infinity. It can be 1000, 1 million, 1 billion. Okay. So this is equal to infinity over infinity. So we cannot find exactly the value of limits. So what we can do, we divide with the highest power of the highest power of x in the denominator. So what is the highest power of x in the denominator? It should be x. So we divide everything with x square. So x divided by x square, 3x square divided by x square, 1 divided with x square. So for the denominator, for the numerator, we get 1 over x. For the denominator, we have 3 minus 1 over x square. So when we substitute the value of negative infinity, so 1 over negative infinity will be 0. Divide with 3 minus 1 over negative infinity square will be 0. So 0 over 3 is equal to 0. It exists. So if you use the calculator, 0 over something will be 0. The one that we cannot find is when we divide 0 with 0. Anything with 0. Okay. So the answer here is equal to 0. So for question C, limit of x plus 1 divide with square root of x squared plus 1. Okay, so we have x and x squared here. So how we find for this limit x approach to negative infinity? So the same as the previous example, we try to substitute the negative infinity first into the numerator and denominator separately. So what we get for the numerator is equal to negative infinity, and the denominator equal to negative infinity square is positive infinity, plus 1 is infinity, and square of infinity is infinity. Okay, both are infinity. So we get infinity, negative infinity over infinity. So there is no certain value of limit. So what we can do, we are dividing with the highest power of x in the denominator. So what is the highest power? So we have x squared. But please remember that we have square root here. So square root of x squared is equivalent to x. So for the terms without the square root, we should divide with x only. So for the term with square root, we divide with x squared. Okay. So for the numerator, everything doesn't have any square root. So we just have to divide with x. And then same as denominator, but as we want to simplify this expression, so everything will be square root lah. So square root of x squared. And then because it's approach to negative infinity, so we just have to take the negative part of the square root. Please remember, if it's a square root on the denominator and then it's approach to negative infinity, then we have to take negative square root only on the denominator. Okay, please remember this. So what we get, so we get x over x equal to 1 plus 1 over x, and then divide with square root of x squared plus 1 over x squared. So it can be 1 plus 1 over x divided with square root negative square root of 1 plus 1 over x squared. So after we replace the value with negative infinity for x, so we have 1 plus 0 divided with negative of square root 1 plus 0. So 1 divided with square root negative square root of 1 is equal to negative 1. So if you forget the negative here, the answer will be positive 1, which is wrong. So please please be reminded when we want to find the limit as x approach to negative infinity and we have square root on the denominator, we should divide with square root of negative here. Okay. For question D, so limit of square root of x squared plus 4 divided with x plus 3 when x approach to positive infinity. So find the limit separately for the top and the bottom one. So we get positive infinity and positive infinity. Exactly, positive infinity over positive infinity means that we have to divide everything with, yes, the highest power of the denominator. So what is the highest power for the denominator here? X. So x, because the numerator got a square root there, so x is equivalent to square root of x squared. So how to write down for the top one? So square root of x squared plus 4 divided by x can be written in the form of square root of x squared plus 4 divided by square root of x squared. Okay, so applying the rule of indices or rule of surds, we get square root of x squared plus 4 all over x squared. And then for the denominator, it's easier because just a simple x plus 3 over x. Okay, simple polynomial. And then, so we get x over x equal to 1 here, and then 3 over x. And then for the numerator, we have x squared plus 4 over x squared, so it should be 1. So it should be limit of square root of 1 plus 4 over x squared all divided with 1 plus 3 over x as x approaches to positive infinity. Now we can do is just substitute the value positive infinity. So 4 over infinity will be 0. 3 over infinity also will be 0. So square root of 1 plus 0 over 1 plus 0 equal to 1. So thank you. This is for 8.1. So we will continue with lecture 3 and next session.